5.2, there's going to be two parts to this first or the second video. So when there's a slide that there's no talking, you don't have to write that down. So first we're going to get into zeros of a polynomial. So it's asking first, what is the factored form? And if I look at all of these three terms, because there's three terms there, I have to take out an x because they all have an x in common. So I'm going to take out the x, and inside be left with x squared minus 2x minus 15. Now, because I took out the x, that's like dividing each term by x, and then whatever on the inside is what's left. So I look at this, and how can I factor this? Two numbers that multiply to get negative 15, but then would add together to get negative 2. So the x stays out in front, and this could be x minus 5 and x plus 3, because negative 5 times 3 would give me a negative 15, and negative 5 plus 3 would give me a negative 2. So this would be my complete factored form. I want you to pause the video and attempt this problem by yourself. So you can first take out the x, like I did right here, and then you'll be left with x squared minus x minus 12. So two numbers again, multiplied to get negative 12. You can always write down the factors of negative 12. So it'd be like negative 1, 12, negative 2, 6, negative 3, 4. And then since it's negative, you can flip around those factors. And the two numbers that would work would be negative 4 and positive 3. So this would be completely factored. So for this problem, we want to find the zeros and their multiplicity. Multiplicity is when a zero occurs more than once. So how often a zero occurs. And this problem is already completely factored for you. You will have to factor some of these. But first I want to find the zeros and their multiplicity. So I'm finding zeros. All these are being multiplied together. So if one of these are 0, then the whole thing is going to be 0. So I can put x minus 2 equal to 0, because my zeros of my function are going to be where it crosses my x-axis. This again would be when each one of these individual ones are equal to 0. So if I'm going to solve all these, for this first one I have to add 2, so I have x is equal to 2. This next one I have to subtract 4 on both sides, so I have x is equal to negative 4. This next one I have to minus 3, so x is equal to negative 3. And here again I have to subtract 4. Now instead of writing x equals negative 4, I'm going to write the multiplicity is 2. And here I'm just going to put quotients. These multiplicities are going to be 1, because it only occurs one time. So again, because negative 4 happens 2 times, it would have a multiplicity of 2. So I have to first factor out here. These all have an x equal, and they all have a 3 in common. So I'm going to divide each one of these by 3x. When I do that, and it's like taking a 3x out of each term. So I have an x squared left minus 6x and plus 9. So now two numbers that multiply to get positive 9 but add together to get negative 6 would be 3x is still left out in front, x minus 3 and x minus 3. They multiply to get a positive 9, add together to get a negative 6. So now when I'm finding my zeros, set each one of those sections equal to 0. And I'm going to solve. And I remember I have to say the multiplicity. Here for the first one, this would just be like dividing by 3 on both sides, and 0 divided by 3, x is going to be equal to 0. This next one I have to add 3 to both sides, so x would be equal to 3. The last one I'm going to have to add 3, so that would mean that I have a multiplicity. So I'm going to write my multiplicity. For this first one, this would just be 1. There's only 1 0 here. There's no, when I look at this, there's no square, there's no cube, there's only one x there. So that has a multiplicity of 1. Where x is equal to 3, there was 2 of those, so this would have a multiplicity of 2. And that is it for this first video. Make sure you wrote down all of the notes. This should be the last problem that I see on your notebook. Have a great, grand, wonderful day.